Welcome back to the Fanatical Futurist. On today's episode, we're going to cover the future of food, including 3D printed sushi, designer humans who don't need to eat, lab-made meat and vertical farms. Plus, we're going to take a look at smart fridges and how they'll not only save you money, they'll make you a fortune. I hope you enjoyed the episode. Matt Griffin, good to see you again, mate.
Yeah, well, likewise, Andy. So, how are you? Any tech issues today?
No tech issues for me, but I know you're having a few issues with your Zoom.
Yeah, joy. Oh, joy.
If anyone was able to see that coming, then the Fanatical Futurist would be that person, but not today. Not today. We've had a bit of a delay, but we're on now, which is good. What have you been up to since we last spoke? I know I'll give you that same question every week, but let's hear it.
So I've been to Saudi Arabia. So I went to Riyadh. So that was earlier in the week.
What were you up to there?
So I was meeting a number of government ministers, including the finance minister. So we're having conversations about the future of financial services globally, of course. Also conversations about the future of financial services within Saudi Arabia and the Middle East itself as well. So we were having conversations about things like fintechs, decentralized finance, tokenization, NFTs, metaverse, Web3, all that kind of different things. But actually, funnily enough, we had an audience of about 500 basically at this particular event, which will go onto the YouTube channel in due course. I showed them how you could disrupt global banking. That's it. So we sort of used a Facebook example that I'm fairly au fait with, but then also showed them how you could disrupt banking using a smart fridge. So if you want to know how you disrupt a bank with a smart fridge, you can either watch the video on my YouTube channel, that's it, or maybe we could dive into it now.
Is it by mining Bitcoin?
Not really, actually, no. So if you want to, so actually that one did come up. So I brought up a new trend that we call crypto cities, which we might have actually discussed in one of the other.
Yeah, we talked about Miami that time with cars that can mine crypto and stuff. What does a fridge do?
So you have a smart fridge. You can buy any smart fridge from Samsung, for example. You connect it to the blockchain. Most smart fridges now are capable of reordering because they understand when you're running out of things. So one of the examples I gave, and I did this with Lloyd's of London basically a little while ago, as well as Lloyd's Banking Group, is if the fridge figures out that you've run out of milk, for example, and you normally pay, let's say, $1 because it's a global audience, for your milk. This fridge also knows that 10 million other people have run out of milk. So it can now form a buying consortium because it's connected, frankly. Now, it's formed a buying consortium. It creates an e-auction situation, and it puts out requests for 10 million pints of milk. An organization, if you're in the Middle East, like, say, Carrefour, basically would actually pick that up. They bid, they win, you end up buying your milk for 80 cents. So you've saved 20 cents, or your smart fridge has now saved you 20 cents.
Right.
Now your smart fridge says, well, what do you want me to do with this? Do you just want me to leave it in your bank account, or do you want me to invest it? Bearing in mind that when we actually have a look at the future of investing, we see robo-advisors all over the place. Some of the best robo-advisors, for example, are in the quantitative trading space, where artificial intelligence, shall we say, investors, but they're called robo-advisors, have actually beating human investors by generating returns of about 64%. So you can sort of go and read about that kind of stuff on Bloomberg. So Bloomberg Quants, go and Google that kind of stuff. So anyway, this fridge takes you 20 cents, gets a fellow robo-advisor to invest it in a low-risk, medium-risk, high-risk fund, depending on whatever it is you're up to. As it saves you money on other goods, all of this money accrues, and eventually we get to the point where these fridges can either end up buying you a Lamborghini, they could maybe fund your retirement. However, if you then start combining these smart fridges and these kind of constructs with universal basic income, when you start running the numbers just in the UK alone, a smart fridge could save UK consumers $362 billion a year on food alone. So you'd end up with a smart fridge with $362 billion worth of cash that it can go off and invest in whatever it wants to go and invest in, provided you've let it. At which point, the robo-advisor, if the robo-advisor did very well, could end up putting that into a universal basic income fund, which then means that the richest entity on the planet could not only be something along the lines of an artificial intelligence, but that artificial intelligence could fund universal basic income for everyone on the planet.
That's crazy. That's what I need. I need a smart fridge or smart something.
Yeah. So I did that. And then other things that I've sort of been up to this week, I've got 2 books now being published. So I was down at the printers this morning, just making sure that the proofs were all okay and everything else. That's it. So
It's exciting.
I know that's looking good. So the first copies will come off the press in about a week and a half's time. So check out LinkedIn. You see some pictures and all that kind of stuff in the Insta.
The thing about your books is they're probably going to date, aren't they? How do you get around that?
So it's a great question. So the way that I design them is they're easily updatable. So my technology codex and my trends codex basically are what I call living books. So they're actually designed to never go out of date, because when you start having a look at trends, for example, as a trend evolves, you just update it. So frankly, it's just a whole bunch of work to keep them current. But I mean, it's like you see a lot of authors will sort of write, say, for example, on synthetic biology. By the time a lot of these books that talk about the future are actually out, the technology has already moved on by generations, which means they're already out of date. That's it. So it is one of the big problems that I actually have now, sort of writing my codexes and my books. So the way that I get around that is I sort of design them in a modular format. I design them with keywords, which very easily let me go in, modify sort of key aspects of it, and then it's bang up to date again.
You should just do podcasts. It sounds easier.
Well, actually, that's why. One of the reasons that I love podcasts is, as we'll sort of find out later with, the news of the week section. Yeah, it's very easy just to say, right, this is the new stuff that you should be looking at. Or this is the new stuff that's weird that maybe you should be looking at, and then go to and run to the hills for. And I've actually got a couple of those coming up later in the episode.
It's hard to do that with a book, isn't it? But yeah, podcasts, you can bang it out so quickly.
Which actually sort of brings us back to this kind of world that we live in now, where we are in this world that is changing so incredibly quickly. That it used to be the case that 20, 30, 40 years ago, if you wrote a book about the future, and you included flying cars, that book would still be current for like 40, 50 years. Whereas now, if I wrote a book about flying cars, we'd have eVTOLs. Then I'd start talking about flying buses, a couple of months later, because we're actually seeing that coming out of New York. That's an odd one.
Well, there's flying buses in New York.
Yeah.
You can't catch a flying bus in New York now, though, can you?
No, but there's a entrepreneur in the US, specifically in New York. And as we start seeing more flying cars being developed, and realistically, flying cars aren't flying cars. They're actually drones, or eVTOLs is their official name.
Oh, is that what you were saying? eVTOLs, so they're drones.
Yeah, or even urban air mobility vehicles. But frankly, a lot of people still use the terminology flying car, and they're not really. They're eVTOLs and UAMs. And when you have a look at organizations like Mercedes, they're developing their Volocopter eVTOL. When you have a look at organizations like Rolls-Royce, Aston Martin, Porsche, they're developing their own. You've got Airbus developing their own, and so on and so forth. But there was this one guy over in New York who sort of thought, well, if we are going to be developing vehicles that fly, it's all very well having flying cars that can maybe take 1, 2, 3, 4, 5, 6 passengers. But when we have a look at today's transportation modes, you have buses, that take sort of 30 to 40 people. So this particular company is called Kellicona, if people want to go and look that one up. And what he's doing is he's creating literally a flying bus. But really, when we say flying bus, you can think of a large flying car, so substitute flying car for eVTOL UAM, that can take 40 people. So we've sort of got some fun things like that sort of coming through. He's estimating that he'll be able to get to market by 2024.
Let's have a look at this week's topic, which is food and how it will impact the climate. Because I think that's a big thing, that it influences everything. Everyone needs to eat. So everyone needs to know how they're going to be getting their food in the future, and everyone needs to know what impact that will have on the climate and how they can live.
So I'm going to pull you up first. That's it.
Oh, God.
Because one of the things that you said is everybody needs to eat. I'm going to tell you a little story here, which you can actually go and verify with NASA, which is a really weird story. So about 3 years ago, NASA, along with the scientific community over in the US, were talking about creating designer humans. Now, one of the reasons why they wanted to create designer humans was because as humans start going on long space missions to, for example, Mars or into interstellar space, one of the things basically that is going to be a significant problem for future astronauts on these long missions is food. How they're going to sustain themselves and everything else. Bearing in mind, we've put human liver cells. People love liver cells for some reason. We've put human liver cells, but also mice into suspended animation. So with mice, we have actually paused with the mice's aging process. So, suspended animation for humans will come along at some point, but realistically, we're still not at the point where we can put an astronaut into stasis or into a cryogenic pod and everything else. So anyway, back to the story. A couple of years ago, basically, NASA was sort of trying to figure out a way to keep astronauts healthy and well on long space missions. So one of the things that they started discussing was the use of genetic engineering technologies like CRISPR to create astronauts that photosynthesize. And they were actually serious. So this is sort of where, when we start having a look into the future, you can imagine a green astronaut floating around in space and everyone's saying, well, you want a pot noodle or something like that. And they're just going, no, I'm all right. The sun's my food. Whether that astronaut would be green or not, I've no idea.
And that is why Martians are humans that have just gone there and photosynthesize and become green.
Well, that's it. So there you go. We solved that mystery. Thanks. That's it. We'll wait for NASA basically to give us a call on that one to thank us for that. When we sort of talk about humans needing food to live, generally, yes. So we'll take the designer astronaut out of the equation. So when we have a look at the future of food, one of the biggest problems that we actually have is by the year 2030, we'll have 11 billion people on the planet. We're going to have more than 600 million more middle-class people. The problem that sort of creates is we have more people wanting more food, but also wanting more protein and more meat. So the answer that we the way that we solve that conundrum today using linear thinking is you go, well, we need more farms, we need more cows, we need more crops to feed the cows, and we need more water for the cows, as well as all the other cattle and animals and everything else. As a result, we also need to deforest more of the Amazon rainforest. Although while everyone focuses on the Amazon rainforest, you should also look at the Borneo rainforest because they're getting deforested at a staggering rate. So I put that in my trends codex recently. That's why I know that stat. So what we have is if we want to feed a growing population and a growing middle class, we really need to change our eating habits. Now, we all see these sort of government communications coming through saying we should all eat plants, or we should all eat bugs. I did a piece of research basically for Samsung where we looked into the future and we did sort of 2069. And they went out to a bunch of different futurists, including myself. And one of the other futurists said, well, in 2069, we're all going to have to eat bugs. And I was like, I don't really want to eat bugs because frankly, I just don't want to. That's it. I don't want to stare a cockroach in the eye and go, I bet you taste nice.
It's so unrealistic to think that everyone's just going to become vegan.
Yeah, exactly. So what I'm able to do now is a few things. So when we have a look at meat, I can take a cell from an animal, and it can be any animal, which is where my freaky story comes in. And I put that cell into a growth medium in a bioreactor, which is a sort of, you can think of it as like a big metal vat. And I can use that bioreactor to grow authentic, genuine meat. It's not plant-based meat. It's not synthetic meat. It's real meat. And the reason why it's real meat is because entrepreneurs have figured out a way, in their terms, to do what an animal does within its own body, outside of its body. So, if you think chickens are made up of lots of cells. A chicken's body is really good at multiplying those cells to give us chicken meat. And then we go off and we farm the chickens, kill the chickens, shove them into a crispy little packet, basically, then feed them to children.
Yummo.
Yeah, yum. Who doesn't like chicken? What we have is today, using something called the clean meat trend, we have a technology that lets us take a cell from an animal or a fish, put it in a bioreactor, and then grow chicken nuggets, duck, fillet steak, and all these kinds of different things. From an ethical perspective, it kind of leads into the question, if you are a vegan and you don't like eating animal products, maybe because it's a welfare question, because I know some vegans by saying it's actually more of a sort of welfare question than, should we say, a philosophy in their particular case, would you eat meat that has not actually come from a living animal?
You definitely would.
So we sort of end up with these weird questions, basically, that the future forces upon us. However, Because we have this kind of technology, I can do a number of really weird things. So I could take a cell from a panda and I could grow a panda burger.
Oh,
Yeah, or a zebra burger. Just to prove the ethics of that particular industry, of this new industry, there was a company called Our Bros. What they did is they took human cells, put them into a bioreactor, and created a human hamburger. So this is where we kind of get into the apocalyptic kind of phase and dystopian kind of phase, where in the future, no one needs to go hungry because you could literally continually eat yourself. The point that they were trying to make was that with clean meat, one of the ways that you grow, for example, beef burgers in a laboratory is you have to use fetal bovine hormone, which comes from pregnant cows. And they were like, well, this is highly unethical and, you can't do it and everything else. So we're going to create a human burger just to prove just how weird this technology is and why it should be banned and everything else. However, little did they actually know that at the University College of London, hey guys, if you're listening, they're actually developing a synthetic hormone that doesn't come from any animals, that is incredibly cheap. And this synthetic hormone will let you still do exactly the same thing. Take the cell from an animal, turn it into a beef burger in a bioreactor. But because this hormone is synthetic, it's dropping the cost of a beef burger, for example, that's made in the lab, from about $1.5 million per quarter pounder, as Google's Eric Schmidt ate about 7 years ago, down to $363 per pound today. And then in about 3 to 4 years' time, this meat that's made in this way should actually be cheaper than supermarket meat. However, unlike meat that has come from, for example, the Amazon, we haven't had to deforest the Amazon. We haven't got a load of farting cows that contribute methane and greenhouse gases to the Earth's atmosphere. We haven't got to have a load of livestock that consumes, in some cases, up to 70% of all fresh water reserves on the planet, which leads to what the United Nations call water wars in 2030. In addition to that, these meats don't contain anything artificial. They're purely organic because you don't need growth hormone. You don't need antibiotics and everything else. So when we actually have a look at these new meat alternatives, I can sit in the middle of a desert with a bioreactor and I can feed the local tribes in the middle of the desert, maybe in the middle of the Sahel, for example, which is desertifying at a terrifying rate. I can feed them fillet steak, day in, day out, on demand. I can do it sustainably as well.
You can do that now, or how far away?
I can do that now. In fact, we've done that in the Middle East. So we've done that, for example, outside of Abu Dhabi. We've also done it in the US. We've done it in Singapore. We've done it basically throughout Eastern Europe, especially.
What's the fuel? Are you just growing, are you growing something from a cell and it's just multiplying? Or are you putting something, so for example, if you're going to make flour, you have to harvest wheat, right? Like if you're growing this stuff in a bioreactor, does it get grown from a cell that multiplies, or do you have to put in some ingredients?
So you have to put in some ingredients, and those are called growth hormones. But those growth hormones are natural, so they come from animals at the minute. But University College of London's research means that it'll be synthetic. The simplest way to put it is what happens inside of an animal in terms of the animal managing to replicate meat-based cells so that it creates more flesh, we can now do outside of the animal.
How long until, you talk about the fridge that can order your meals, how long until you've got the fridge that can grow your own meals? So you put in an order and you're like, I want this week, I want salmon, I want fillet steak, I want chicken. And then the technology is in the fridge that you're talking about, that these scientists have got, that make it all for you. And you open your fridge and you're like, I've grown a chicken nugget or whatever it is.
So when we look at the future of food production, we can take a cell, put it in a bioreactor, create a chicken nugget. We can also 3D print a chicken nugget. We can also 3D print beef. We've 3D printed beef on the International Space Station with a company called Aleph Farms. So we can 3D print food as well. We can 3D print fruit. We had a company out of Cambridge a couple of years ago that 3D printed raspberries using something called spheroidal 3D printing and all that sort of stuff. So while it still takes time to actually grow, for example, a beef burger in a bioreactor, You could conceivably put something called a chef jet, which is a 3D printer, but it's a 3D food printer, either into your kitchen, really, because that's probably where it'd go rather than the fridge, but you could put it into a fridge. These 3D printers can 3D print gourmet food. So there was a company in the UK called Food Inc. They would open pop-up restaurants, and what would happen is you'd walk into this pop-up restaurant, they'd charge £250 per head, and they would 3D print all of the food for you. There's a company called Open Table in Japan that actually I've sort of recently come across. They 3D print sushi, but because we're 3D printing food, they will 3D print sushi, but the sushi can have very, very intricate designs and all that kind of stuff. I mean, technically, you could even 3D print your face into a piece of sushi and then eat your face, both figuratively in terms of an image of your face, but also literally if you take the our Boros experiment that they did. So that'd be freaky, thinking about that. God. Now, when we start combining these kinds of technologies, for example, with connected home, and say your Apple Watches, other watches are available, a watch could figure out that I was actually stressed at work. It could track me on my way home from work, and the fridge knows that my favorite comfort meal is, I don't know, chocolate lasagna, and it could have that printed for me when I get home. When you start combining all these different technologies and trends together, you actually get a fundamentally different type of lifestyle. In addition to that, when we start combining quantified self and personalized medicine with 3D printed food, especially, Nestle have turned this into a $1 billion business over in Japan. You can 3D print food that is matched to your particular, whether it be genome, biochemistry, or whatever it happens to be, which means that the food that your fridge, if you really want to stick it in a fridge, prints you, is tailored to your own specific biomarkers, biochemistry, genetics. If you've been using noone to do some genetic sequencing for you. But genetic sequencing, courtesy of organizations like Minion, basically will end up being in a watch, in about 10 years' time, because sensors are getting more sensitive. So there's loads and loads of different things that we can do. And then as we start having a look at things like crops, because people might say, well, I want salad with my 3D printed human hamburger, or my clean meat human hamburger. This is where we have vertical farms. So Jeff Bezos has invested $250 million in a company called Plenty. We've got Aero Farms out of the US, out of Jersey. We've also got Inox, so hey to Inox. So Inox, basically all these different organizations are creating vertical farms now, typically in cities with a million or more people. And they're growing what we call tier 3 crops. So you can think of those as your salads, like your kales, your cabbage, your lettuce, all that kind of stuff. But they're growing them in essentially an Amazon warehouse, which then means that when you order, say, a lettuce from Amazon fresh, it used to come from a farmer, for example, in Spain. Now it comes from an Amazon warehouse that's next to you in Slough in the UK. We cut out food miles and everything else. But by growing crops in vertical farms, you can have 8 times the yield. You can use up to 100% less potable water. And I'm going to explain that bit a little bit. So a vertical farm is a closed loop system. So because of its very nature, we can reduce the amount of water consumption that we use to grow crops using things like hydroponics, precision agriculture, and so on by about 98%. But if you put 3D printed heat exchangers on the roofs of these vertical farms, those heat exchangers can extract hundreds of liters of water from the Earth's atmosphere every single day. So that means that the vertical farm no longer has to draw water from the local aquifer or the local potable water source or whatever it happens to be. These crops, in addition, they have no chemicals, no herbicides, no pesticides. So they are, again, by definition, organic. It's also a manufacturing process, which is where Inox come in, because they've created fully autonomous vertical farms. And then because the produce is grown next to a city, if you're in Dubai, we've got vertical farms on the Sheikh Zayed Road, and those vertical farms supply the restaurants in Dubai Mall. When we start having a look at how we produce fish without the fish, meat without the animal, crops in new ways, we've got a whole variety of different technologies that we're actually using today that people can go have a look at, walk around, prod and poke, and then taste. If you go to restaurants in Singapore now, you can buy chicken nuggets because they've been regulated. You can buy chicken nuggets in restaurants that have never, ever come from an animal, that aren't plant, they aren't synthetic, they aren't some odd, weird concoction of anything else. They are the real deal.
Expensive.
No, well, so they are more expensive. They're about 3 to 4 times more expensive than traditional chicken nuggets. But bearing in mind that one of the key attributes of exponential technology is over time, the cost performance of exponential technologies falls dramatically. You know, if you have a look at the cost of storage today, it's basically free. Whereas if you go back to 1956, you could buy a megabyte of storage from a company like IBM for about $73 million. You know, and same with computing, same with digital photography. You know, it used to be the case if you wanted to take a photo, you'd have to go off and buy your expensive DSLR camera, use film, get it developed and everything else. I mean, how much does it cost anyone now to take a photo and store a photo? When we have a look at things like communications, you know, if you want to phone your nan over in Australia, that's it. Well, actually, you know, or even your rallies in New Zealand, Andy.
Exactly.
It's free. You know, that's it. You jump onto a Wi-Fi network, you use WhatsApp, it's free.
Yeah, it used to cost so much, but now, yeah, you're right, it's free.
Exactly. So what we see is, from a cost perspective, the cost of producing food in vertical farms is now almost at a parity with the cost of food that is produced in a traditional way in a supermarket, except it's more sustainable than everything else. When we have a look at meat, the prices are still about $363 per pound for things like beef burgers, steak, duck, chicken, you know, before we even start talking about zebra and pork bellies and all that kind of stuff. But that has come down from, doing the calculation, $6 million per pound about 7 years ago. So the costs are falling. And as I say, you know, when you have a look at the cost of buying chicken nuggets that were produced in a lab, which people might not like it being produced in the lab, but that's a marketing term. You know, you just go, this was lovingly produced in a factory outside of Dulwich. But, you know, when we start having a look at being able to buy lab-grown meat from a supermarket at a cost that is comparable to the chicken that we buy off the shelves today, that's about 4 years away. And when we have a look at chicken today, for example, you know, over the past couple of years, we've had chicken shortages. KFC ran out of chicken. We've got bird flu coming back. In the UK, we have such a problem with bird flu now that the free-range chickens are no longer able to go out and be free-range. They can't go around the fields and everything else, which means for the first time ever, if you go to the likes of Tesco's and Sainsbury's and all these other supermarkets, Asda, et cetera, you can no longer buy chicken eggs that are free range because the chickens haven't been allowed out of the barns, which then brings us on to, you know, we can also use this trend, and it's called cellular agriculture, to produce soy, wheat. We can use it to produce whey, palm oil. So I've worked with quite a lot of food companies all around the world, especially in the US and over in Asia. And, you know, at the moment, basically, we're talking about lab grown, you know, you can call it synthetic, but lab grown palm oil. You know, palm oil is one of the most devastating crops on the planet because it is the ultimate monoculture. And we have a way to do away with that. We can also use cellular agriculture in exactly the same way to create leather without the cow. We've got Modern Meadow over in New York doing that with fashion. We can also, courtesy of MIT, take a cell from a tree and create lab-grown wood, which then means that we can grow mahogany, for example, or rosewood in a lab, and we no longer have to actually go and deforest Borneo. And this is sort of one of the things I kind of like about technology is once one human figures out how to do something, take a cell from an organism, grow it outside of that organism to produce wood, leather, fish, meat, you know, whatever it happens to be. All of a sudden, the rest of the world's entrepreneurs look at it, jump on it, and all of a sudden, you know, everywhere you turn, you see food being made in a new way. So we need to transition from the old way of doing things to the new way of doing things. You know, this is kind of the food moments, Henry Ford moment, where we sort of go, we used to have cows wandering around, you know, the Amazon rainforest, you know, as the rest of the rainforest just burns around the cows. But now we don't. It's the equivalent of going from horses to cars. It's that much of a leap. But from a human society perspective, it gives us a way to sustainably feed every single person on the planet with the finest Wagyu beef, the finest lettuces and kales and everything else in a brand new way.
Let's have a look at the news of the week. What big news have you got for the future that's here today?
So this has sort of been a every week's an interesting week from the future of news perspective. But, so for anyone who's following this, you can go to my blog, which is FanaticalFuturist.com, reading out just a couple. So we've got DARPA, which is the bleeding edge research arm of the US military, which is actually messing about with creating living factories in space. So this is where we have genetically modified bacteria, essentially throw them into space, ideally onto the moon, and then those bacteria create resources for us, whether it's things like water, whether it's minerals that we can then use to make lunar habitats and all that kind of stuff. So it's kind of a biomanufacturing trend. It's an interesting one, kind of goes along with the biomining trend, where we actually use bacteria on the moon to mine precious minerals out of the moon's regolith. That's an odd one and a little bit of a fun one. Then we've got robo-advisors. So robo-advisors, actually, we talked about the smart fridge and the robo-advisor a little bit earlier. We've got robo-advisors are now starting to make more inroads into retail traders. So particularly in the financial services industry, if you want to invest in something, we've seen robo-advisors increasingly being used at quite a lot of the large banks to supplement the advice that is given by human traders. So we're still in this kind of position of human plus artificial intelligence, as opposed to artificial intelligence running the show. With the war in Ukraine, I've seen Europe pushing a new type of fuel called solar fuels. So it's no secret that Europe wants to get itself off Russian oil and gas. So while they are importing liquid LNG from countries like Qatar, and while the European government are increasing the amount of investment in traditional wind and solar farms and all that sort of stuff, that takes time. One of the other areas that they've sort of been investing heavily in, or more heavily in, is artificial photosynthesis. So this is where we are able to use artificial photosynthesis to turn common garden, carbon dioxide, sunlight, and other sort of bits and bobs into diesel. So this is where, rather than going to Russia and saying, hey, Russia, can you sell us a load of diesel? We have artificial photosynthesis sort of factories that just produce diesel from fresh air. And that's actually not a new thing, if people are wondering. That's been around for a while, but Europe's accelerating the push on that. We've got artificial intelligence now being able to figure out how life works. So this is sort of where, when we have a look at the Human Genome Project, the Human Genome Project has managed to unravel all of the human genome now, but artificial intelligence is increasingly figuring out how all of the little molecular machines in our bodies do what they do, because our bodies are really complex and all that sort of stuff. So this is sort of where we talk about, how RNA combines basically with different codons or different things basically in our cells. So AI basically is increasingly figuring out how the little biological machines that govern life itself are working.
That's scary.
Yeah, well, that's a whole conversation about artificial humans, actually.
Yeah, exactly.
Courtesy 2036, courtesy of MIT, University College of London. Hey, guys, again, coming up twice now in the podcast, as well as Harvard and MIT. And I think University of California are looking at creating a fully synthetic designer human genome, which they can then use a 3D bioprinter to print out in 2036. Although the AI recently created a synthetic human genome, so it beat them to it by about 15 years. Then we've got quantum computers. So quantum computers, which are still relatively newish technology. We're up at about 126 qubits. Really, when we get a quantum computer that's 1,000 qubits, then that's a game changer. That's in about 2025. We've had a bunch of scientists and researchers using quantum computers to try to simulate chemistry, and quantum synthetic chemistry, as it's now known, is an upticking trend. So this is where a quantum computer can figure out a new chemical compound in seconds that would have maybe taken humanity decades or never. So the simulation of chemistry. And then I suppose, last week we talked about the future of defense and all that kind of stuff, sort of moving the defense bar now. We had a research project over in the US. And what they wanted to do is they wanted to try to understand how artificial intelligence could be compromised. So what they did is they set an artificial intelligence the task of trying to create new synthetic chemistry molecules for good. And the AI managed to do it really well. They then tweaked the artificial intelligence a little bit to see if they could get it to produce something a little bit nastier. This artificial intelligence created 40,000 new chemical weapons within 6 hours, which when you tie that into a Skynet-like construct and fully autonomous hunter-killer robots and everything else that we already have the technology to build and deploy, and which Turkey has kind of already deployed, different story, according to the United Nations. Look that one up. That's a fun one. However, I kind of said that when I wrote that particular piece of news, I said, artificial intelligence has now managed to create 40,000 new chemical weapons compounds in just 6 hours. And if you have a look at the mainstream media, they've all sort of gone, oh my God, But I kind of went along with the lines of saying, well, actually, that's kind of fine. Because elsewhere, I wrote an article about 2 years ago based on a piece of research that I saw coming out of DARPA. DARPA, for the past couple of years, again, the US bleeding edge research arm, hey guys, they currently have a project to try to see if they can genetically engineer American soldiers so they are immune from bioweapons and chemical weapons. So it looks like DARPA is already 2 years ahead of this particular artificial intelligence trend, which is good. And then in the future, if we do have an artificial intelligence that decides to kill us all with chemical weapons, then courtesy of other technologies elsewhere, we could put a genetic engineering tool like CRISPR into an aerosol, which is already a thing, and it could actually end up re-engineering our genome in vivo, which it's also already done, both for cystic fibrosis as well as for Hunter's syndrome in the healthcare space, because it's a benign technology. It's not designed to be weaponized or militarized. So we do maybe have a way that we can defend ourselves against a killer artificial intelligence in the future that has decided it wants to create a load of new bioweapons and chemical weapons.
Well, there's some good news to finish off the news section.
We're going to end up on a happy note, haven't we?
Let's finish off the podcast with the innovation of the week.
Now, we all know that we can use artificial intelligence to translate human language. So we can use Google Translate to translate English into French, French into Mandarin Chinese.
Please tell me I'm going to be able to talk to a cat or a dog.
Oh, yes. So more than that, though, this particular innovation has been using artificial intelligence to decode pig squeals. So we can actually figure out whether pigs are happy or not. Now, if anyone's sort of going, well, why would you want to do that? It's actually for animal welfare purposes, which actually, ironically, you wouldn't need if you take the cell from a pig and then you create pork chops, which is something that someone in Cambridge has done, by the way. So in the future, we don't actually need pigs, which makes this innovation useless. So sorry, researchers, However, what they've managed to do is they've managed to decode sort of pig squeals. They're now going to use that to decode the pig's language. But elsewhere, we've been using the same kind of premise to decode mice chatter as well as dolphin speak. So this kind of leads us on to, if we can use artificial intelligence to help translate English to Chinese, Chinese to Arabic, Arabic to, Spanish and so on and so forth, animal languages are just a different language. And artificial intelligence is getting increasingly good at understanding all of these kind of different languages, which then means when you extrapolate this particular innovation out, we have the beginnings of a true universal translator like we see on Star Trek, where you can go to a different planet inhabited by dolphins and just go, yep, that's fine. You want fish. That's it. I've got some lab-grown fish basically in my spaceship. Would you like that? Have that on us. Peace to all dolphins. Shall we form an alliance? So that's my favorite innovation this week.
That's cool. That is cool. Matt Griffin, thank you very much for your time. Great way to finish.
Cheers, Andy. Cheers, everyone.
For more information on the topics discussed in this podcast, just check out 311institute.com.